Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this problem using the concepts of rational function. As per the problem, state the intercepts, asymptotes, end behaviors, domain and range for f at x equals negative 3 over 2x minus 5. Sketch the function. This given function is a rational function. It is a reciprocal of linear function. Let's start by finding the intercepts. For x-intercept, we sub in the function value as 0 in the given equation and solve for x. We can cross multiply the denominator. 0 times 2x minus 5 is equal to 0. There is no x term in this equation. That means this function has no x-intercept. Now we can find the y-intercept. For y-intercept, we should sub in x as 0 in the given function equation. Two times 0 is 0. 0 minus 5 is negative 5. The two negative signs get cancelled out, so the final answer is 3 over 5 or 0.6. This is the y-intercept. We can write it as an ordered pair as 0, 3 over 5. Next, we can find the vertical asymptote. For vertical asymptote, we should set the denominator expression equal to 0 and solve for x. I get x equals 5 over 2. This is the vertical asymptote in this rational function. Now we can find the horizontal asymptote. In the given function, the degree of the numerator expression is 0 because there is no x term in the numerator. The degree of the denominator expression is 1 because of the x in the denominator. Since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is at y equals 0. There is a very important concept we need to understand and memorize for this type of problem. Next, we can find the end behaviors. Let's start with the end behavior around the horizontal asymptote. We check the end behavior around the horizontal asymptote at the extreme left and extreme right. On the extreme left, we check for x approaches negative infinity. We have to find whether the y value approaches 0 from above or below. We check for 0 because the horizontal asymptote is at y equals 0. On the right side, as x approaches positive infinity, we have to check whether y approaches the value of 0 from above or below. For the first test, x approaches negative infinity, we can use a big negative number for x. We should sub in x as negative 100 in the given function equation. 2 times negative 100 is negative 200. Negative 200 minus 5 is negative 205. So we get an overall positive value. Since a positive value is greater than 0, that means y approaches 0 from above. Next, we do the check for the right side. We should sub in x as a big positive number, 100. In the denominator, 2 times 100 is 200, minus 5 is 195. So we get a negative overall value. So on the right side, y approaches 0 from below. So this is the end behavior for the horizontal asymptote. Now we can find the end behavior for the vertical asymptote. We have to check for the end behavior on the left side and the right side of the vertical asymptote. And we have to find whether y approaches positive infinity or negative infinity. For the left side of the vertical asymptote, we can use a test value very close to 5 over 2. 5 over 2 is equal to 2.5, so we can use the test value 2.4 for the left side. We should sub in x as 2.4 in the function. In the denominator, 2 times 2.4 is 4.8. 4.8 minus 5 is equal to negative 0.2. So the overall value will be positive. That means y approaches positive infinity. Next, we can do the check on the right side of the vertical asymptote. We can use the test value 2.6. In the denominator, 2 times 2.6 is equal to 5.2. 5.2 minus 5 is 0.2. The overall value will be negative. So y approaches negative infinity on the right side of the vertical asymptote. Next, we can find the domain. In the domain, we have to exclude the x value where the vertical asymptote exists. So the domain can be written as xer, and x cannot be equal to 5 over 2. In interval notation, the domain can be written as next we can write the range. The range has to exclude the y value at which the horizontal asymptote exists. So the range can be written as In the interval notation, we can write it as now we can use all of this information to sketch the function. Let's start with the intercept. There is no x-intercept and the y-intercept is at 0.6, so somewhere here. The horizontal asymptote is on the x-axis. The vertical asymptote is at 5/2 or 2.5. Now we can show the end behaviors. On the left side, the function approaches the horizontal asymptote from above. On the right side, the function approaches the horizontal asymptote from below. On the left side, the function approaches the vertical asymptote in the upward direction. And on the right side, it approaches in the downward direction. Now we can join these end behaviors through the y-intercept. So this can be the sketch of this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.